Good evening. Now we'll discuss 8, 8251, which is also called as Usart, USART, Universal Asynchronous, Transmit and receive and transmit. The universal, synchronous, asynchronous, receive and transmit device. This is used, so basically why we require this 8257 is to input or output data transfer in all microprocessor and microcontroller systems is classified into two types. One is serial data transmission, and second one is parallel data transmission. Parallel data transmission. Most of the devices are parallel in nature. Microprocessor 8085 is a parallel device, or 8051 is also a parallel device and is designed for 8-bit parallel data transfer. When 8-bit microprocessor transfers 8-bit of data simultaneously on its 8-bit data lines, then it is called parallel IO, parallel input output mode. But a parallel data transfer process is very complicated and expensive. Therefore, hence, in some situations, serial IO mode is used where one bit is transferred over a single line at a time. So for cases, a parallel word is first converted into a stream of series bits before transmission, and this is called as a parallel to serial conversion. The rate of transmission in serial mode is baud and bits per second. In data communication, the interface must convert a parallel data to the serial form for a transmission and must convert a serial to parallel after receiving. The interface should be capable of inserting or deleting bits and characters. So the USART satisfies all requirements. So this particular device, 8251, is a device which converts parallel data to serial and serial data to parallel. So in some applications here, 8085 and as I said earlier, 8085 and 8051 both are parallel device. We can transmit a data parallel to the processor or controller, but it is a very complex process. So therefore, converting here first, we need to convert a serial data to parallel. Parallelly, we have to give to the controller or microprocessor. But while sending outside the world, we need to send in a serial manner. So therefore, we require one interface device which converts a parallel data to serial or serial data to parallel data. So this is fulfills with the help of this 8251 IC. This 8251 IC can be used as serial communication interface, and this is also called as PCI. This is PCI, programmable communication interface. Programmable communication interface. This is very, very important. Now we'll see the block diagram of 8051. First, I'll draw the block diagram, then I'll explain. This is the block diagram of 8251, sorry, 8251, where mainly this is a data bus buffer. This is the data bus buffer. where this data bus buffer is this D02 D7 8-bit, and it is used temporarily to store the data which is to be transmitted. So data is to be data is to be stored and data bus buffer which is to be transmitted or received, which is to be transmitted or received. And next one is read write control logic. In read write control logic includes the 6 input pins. The 1, 2, 3, 4, 5, and 6 input pins are there, and control logic and 3 buffer registers are also there inside this read write control logic. And this is a bus of this is the internal buses which transfers the information from one block to the main bus or another, like this. Data transmission is possible with this one. Yeah, I'll explain. This is chip select line, and C by D bar is a control and data, and clock signal is required for internal operations. Reset signal is required. Read and write operations. Read operations from the receiver and write operations onto the transmit, which has to be transmitted into uh, through wires and clock signal. So three buffer registers here. The first buffer register is control register. This control register is used. Control register is a 16-bit register, and for a control word consisting of two independent bytes. First byte is called in this first byte. First byte is for mode instruction. Mode instruction, and second byte is for command instruction. Command instruction. Here in control register is a 16-bit register. Control word consisting of two independent bytes. First byte is for mode instruction and second byte is for uh, command instruction. And this register can be accessed as an output port, and this register can be used as an output port when C by D bar is high. C by D bar means here this pin. C by D bar high means command. When control and data, the command signals. If it is one, then we can use as a output registers. Output register. And second important register is three buffer registers will be there. In that three first buffer register is a control register, and second one is a status register. And this status register, what is the function of this status register is that status register is input register. This is an input register, checks the ready status of peripherals, whether the transmitter is ready or not, whether the receiver is ready or not. And these ready status can be read with the help of this status register. And this register is addressed as input port when C by D bar pin is high. Here, if it is 1, this control register can be used as an output port when C by D bar pin is 1. And this status pin is used as an input port. This status pin is used as an input port when C by D bar equal to when C by D bar pin is high. Again. And this is also this used as an input port. And it has the same port address of the control registers. Port address of control register and status registers are both the same. And third buffer register is data buffer. Data buffer register. And data buffer register, this is a bidirectional registers. It can send the data or receives the data. Addressed as a input port and output port when C by D bar pin is. This can be here. This C by D bar, the data bus buffer, a data bus register, data buffer register can be used as an input port and output port when C by D bar is equal to 0. It acts as an input port as well as output port. And next one is transmitter section, and these two blocks, where these two blocks consisting of transmitter section and transmission section accepts the parallel data from the microprocessor unit. It accepts here, that's why I was only one direction. This is, it accepts the parallel data. It accepts the parallel data from the controller, from microcontroller or microprocessor, and it converts them into serial one. See, converts them into serial data. This is the serial output code, serial data transmission, serial data transmission, and it has a two registers. This transmission section mainly has a two registers. One is buffer register. Buffer register. The function of buffer register to hold 8 bits, to hold 8 bits, and whereas the output registers are there. Next one is output register. The output register to convert 8-bit into stream of serial bits. This 8-bit data converts serially one bit stream, converts into bit stream, serial bit stream, serial bit stream. The microprocessor writes a byte onto the buffer register whenever buffer registers. Actually, we have to write a data which has to be serially transmitted over the lines that can be stored in a buffer registers. So whenever output register is empty, whenever output register is empty, then the contents of buffer registers are transferred to the output register. When output registers is empty, the contents of buffer registers, these buffer registers, the contents of buffer registers is loaded onto the output registers and transmits the data to the TXT pin. Transmits the data on TXT pin with a frame of bits. And transmission section has 3 output signals and input. It has a 3 output signals, 1 input signal. 3 output signals and 1 input signals. They are TXC. Here, this is TXC transmitter clock. And this input, this is an input signal, controls the rate at which a data is transmitted over serially, like a 16 bits per baud rate, 64 baud rate, and this decides the rate at which we are transmitting the data to external peripherals. And whereas the TXD is the data, serial bits are transmitted on this line. Serial bits are transmitted on this line. Serial bits are transmitted on this line. And next one is transmitter ready, TXRDY. This is a transmitter ready, and this is an output signal. When it is high, when this signal is high, it indicates that a buffer register is empty, and 8251 pin is ready to accept the byte, and it can be used either as interrupt the microprocessor unit or indicate the status. The signal is reset when data byte is located onto the buffer. And next one is TXE, transmitter empty. This is an output signal. Logic 1 on this line indicates that the output register is empty, and this signal is reset when the byte is transferred from the buffer to output registers. And this signal will get resetted automatically when a byte is transferred from buffer to output registers. Basically, this transmitter section has 2 registers. One is a buffer registers and output registers. Buffer registers hold the data to be transmitted, data to be converted from parallel to serial transmission. And this is a clock signal. This is transmitter empty. This is a transmitter ready, and this is a transmit data transmission, serially data transmission on this line. And next one is, this is a receiver section. This is a receiver section. In receiver section accepts the serial data. It accepts the serial data from the peripherals. Serial data from peripherals and converts them into parallel one. That's why converts come into parallel data. Here the parallel data. Parallel data. And it has a two registers again. Similarly, as like transmitter section. First one is input register. Input register receives the serial data and converts into parallel data. In the function of input register is, it receives the serial data from the peripherals and converts into parallel data. And second register is buffer register. Buffer register, the function of receiver section buffer register is, it holds the previous converted data. When RxD line, when this line RxD received line goes low, becomes low, when it is low, the control logic assumes it is a stored bit. If it is here, when the RxD is equal to 0, it is assumed that it is a stored bit and waits for half a bit time and samples the line again. If the line is still low, then input register accepts the following bits and forms a character and loads it into the buffer register. Here once again, when RSD signal line is low, the control logic assumes it as stored bit. That is 0 is a stored bit and waits for half a bit time period and samples the line again. If the line is still low, then input register accepts the following bits and characters bits and forms a character and loads into the buffer registers. Accepts the bits and forms the characters and loads into the buffer registers. And next, this in the asynchronous mode, it has two input signals, one output signal. See here, these two are output signal, ready and send date and VDD. In the synchronous for a synchronous operations, and Rx is a receiver clock. RxD, as we know, is a function of RxD is the received data. The bits are received serially on this line and converted into parallel byte at receiver at input register. And next, receiver clock RxC. This is a clock signal. Here, this is a clock signal. It decides at what rate we are receiving the signal. At what rate which bits are received by the USART. The synchronous mode clock can be set to 16 or 64 times of the baud rate. Next, receiver ready signal will be there. This is an output signal. Again, this is an output signal. It goes high when 8251 has a character in the buffer registers. Yeah, when character in the buffer register, it becomes 1. Ready signal will become high. And ready to transfer to the microprocessor. And this, when the data or a character is loaded onto the buffer register and it is ready to transfer the data to the microprocessor or a microcontroller. And this line can be used either to indicate the status or interrupt the microprocessor unit. And last, this is an output signal again. During asynchronous mode, this synchronous data transmission DET signal is used to indicate the break in data transmission. To indicate the break in data transmission in asynchronous mode, whereas during a synchronous mode, it is used to indicate the break in data transmission. Break in data transmission. both both synchronous and synchronous. If there is any data break in data transmission, then that is indicated by this line. And this is all about, this is a modem controller. This is a modem control. What these lines are, one is input line, another one is output line. This is a modem controls. Yeah, also it selects the data rate, and DSR is the data set ready. When this is low, 8251 has a ready to set the data. And whereas a DTCR is an output signal, data terminal read. When it is low, all these are active low signals. That's why when it is low, 8251 has ready to set data terminals. And whereas RTS is a request to send. When it is low, again active signal, 8251 has ready to set the data. And CTS is clear to send. And this is when it is low, enables pin 8251 enables the 8251 to transmit a serial data. And this is a serial data transmission. Data set ready and data terminal read, clear to send and request to send. And these are the control signals, error command signals used in modem control. Modem control. Here, this is all about a block diagram of 8251. Thank you. I'll stop here.